Hey guys, welcome or welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with the fourth problem of my AIME series. Today's problem comes from the year 2020 and it's problem number 4. I hope you guys enjoyed this video and let's get started. The problem states, let S be the set of positive integers in with the property that the last 4 digits of in are 2020. And when the last 4 digits are removed, the result is a divisor of in. For example, 42020 or 42,020 is in S because 4 is a divisor of 42,020. Find the sum of all the digits of all the numbers in S. For example, the number 42,020 contributes 4 plus 2 plus 0 plus 2 plus 0 is equal to 8 to this total. So essentially, this problem tells us that for a set of S, there are numbers in which the last 4 digits are always going to be 2020. And then in the front, we can have as many digits as we would like, but it doesn't matter what we have in the front numbers has to be a divisor of the whole number in all. So example, it tells us that 4 would be a divisor of 42,020 because, again, if we would take out the 2020, then that's where we got the 4 from. So knowing this, we should figure out that the numbers in the front must be divisible by 2020. And that's just because it tells us that when the last 4 digits are removed. So if we don't look at this, the result, so simply the numbers before the last 4 digits, is a divisor of in. So if we put it and divide it, that means that whatever we have in the front, it'll just be A, B, C, D. Whatever we have in the front must be divisible by A, B, C, D, 2020. And then so this would divide into all the first numbers before 2020 because that's the exact same numbers. So it's up to if A, B, C, D is divisible by 2020. So what we want to do is we are just going to find out the factors of 2020. So we would have 5 times 2, 1 times 5 times 2, times 2 times 101. But these are not all of them because there are many other different ones. For example, if we get 5 times 2, and then 2 times 2, 5 times 101, 2 times 101, 4 times 101. So there are many combinations. And so we can just write them out. So it'd be 1, 2, 2 times 2, 4, and then 5. And then 2 times 5 is 10. 5 times 2 times 2 is 20. And then 101 by itself. 101 times 2 is 202. 101 times 4 is 404. 101 times 5 is 505. And then we have 101 times 10. And then 2020. So these are all of the factors of 2020. And so that means we have, in the set of S, we have numbers such as 1, 2020, 2, 2020, 4, 2020, 5, 2020, and so on all the way until 2020, 2020. So essentially, we're just taking the factors and putting them in front of 2020. But it's asking us to find out the sum of all the digits of all the numbers in S. So we can calculate this by first just looking at what they all have in common, which is 2020. Well, keep in mind that the way it counts the sum of all the digits is simply just adding up the digits. So they all have 2020, and 2020 is just 2 plus 0 plus 2 plus 0, which is simply 4. So we have 4 of the 20, which comes from 2 plus 2 in 2020. And then how many of these do we have? Well, we have 12 of these because, again, we have 12 of the factors and we put the 12 factors in front of 2020. So that means we have 4 times 12 of these sets, which gives us 48. And so that means that we got rid of the issue with calculating the last 4 digits of each number, which was 2020, and now we just have to add up the digits in front. So all we have to do is just add all these numbers up. 1 plus 2 plus 4 plus 5 plus 1 plus 0, which is just 1. 2 plus 0, which is 2. And then 101, there are 2 ones, so it's just 2. Plus 4 plus 8 plus 10 plus 2 plus 4. So I'm just simply again adding up the digits in the numbers. And this gives us 45. So all we have to do is just add up 45 plus 48 to get 93. So our answer would be 93.